Yeah, so good afternoon, and first of all, thanks to the CMAC team for putting on such a great event. Sorry I couldn't be here yesterday. I had some train delays in terms of getting here. I very much enjoyed the first day, my first morning here. A couple of things maybe to observe. I come into this as a non-pharmaceutical person. I always come into these sessions thinking, I'm not a non-pharmaceutical person, what can I add? And then by the time I get through about 3 presentations, I realize the commonality of issues that are experienced when people talk about digitalization in manufacturing and supply chains. And I feel a bit like I have more that I can offer. So what I'd like to do is give you a little bit of an overview of my program. I'll set the scene a little bit about the wider context in which this centre operates, and just sort of maybe pick up on some of the themes that Mark and others have touched on this morning. So if I look across the last couple of years, and this sort of times in not just with the pandemic, but I joined UKRI 2 years ago. I joined to take on this particular opportunity. And in about May 2 years ago, so almost exactly this time 2 years ago, I'm sitting in meetings with government ministers. We're in the teeth of the pandemic. We're allowed at 1 hour a day. Everybody thinks the manufacturing sector could potentially collapse. There's a whole bunch of challenges about it, but it was never going to quite be like that. We saw a surge in demand for food, surge in demand for vaccines. Suddenly nobody needed to fly anywhere. People were making ventilators and so on. So 2 years ago, the world looked very, very different. It's pretty obvious, really, since it's been obvious for everybody who's in the sector already about the importance of manufacturing, but it was genuinely inspiring being part of some of those meetings and seeing what some of the manufacturers were doing. And I think, they've, in this sector, vaccines, I mean, how inspiring is that? But again, if you look at ventilator challenge, response to the food system and so on, it's really, really inspiring stuff. But global supply chains are complex and face ongoing shocks. It's not just a kind of a one-off thing that will happen once a generation. Even in the 2 years I've been here, we've had, dare I say, Brexit, COVID, Ukraine issues, Suez, and so on. The sort of nature of dealing with ongoing disruptions, whether it's ongoing pandemics or ongoing other crises within manufacturing, is a major, major issue. And if you fast forward to what that means, if I look across the sectors that I look at and see what they're doing, there'll be an enormous transformation both needed and will happen anyway in terms of the products we use, how we use them, how they're made, how they're delivered, how we recycle, how we reuse them. If you fast forward to delivering what was sort of called the net zero production system of, let's say, 15 years away, and imagine that scale of transformation across all sectors, then it obviously provides an enormous opportunity. Underpinning a lot of that, it's not the only part of it, but the critical importance of collaboration, of innovation, of digitalization, how they interplay with each other, I think going forward, is a major, major part of that. So one of the questions I was asked literally 2 years ago is, do we need any digital innovation investment right now? Has the world got any capacity for it? What we saw actually is from even in manufacturing companies who saw declining affordability for investment, their increase in desire for digital innovation went through the roof. We had no problems being oversubscribed for competitions that we ran. No shortage of innovation. Each of the sectors have, I guess, everybody's got slightly different challenges. So there's probably 75% of what Mark said just before lunch that is absolutely common across sectors, and the same with Rob. If I just lifted that presentation and put it into an automotive environment or an aerospace environment or a chemicals environment, you'd find very similar issues. How do you fast forward into net zero operations? How do you embrace circularity and sustainability in terms of what you try and do? How do you deliver supply chain resilience and traceability? Everybody wants traceability of their goods. Where has this shirt come from and who's made it, through to sourcing critical materials and where have they come from, through to its end-of-life usage, through to its critical in terms of quality from a pharmaceutical point of view. So how do you do all that? And those are common issues. Skills and the future of work is a massive topic. How can we use digital technologies, from my perspective, to deliver a better future of work? More job satisfaction, higher skilled jobs, higher paid jobs, primarily here in the UK, but of course everywhere else. How do we deliver that positive future of work and use digitalization as a tool to get us there? And whether we embrace it or not, the technology is accelerating, is changing. I really liked Mark's timeline. It kind of probably mapped with my career timeline, very similar. We have used different terminology for more or less the same thing for most of the last decades. It was big data 10 years ago, then it was AI, and now it's digital twins, but it's fundamentally a lot of the same things are underneath it. But that technology is happening, so how do we harness that for good? And I think if I look across all the sectors genuinely and I see the stuff they're doing and I see the challenges they all face, the need to innovate and industrialize those kind of new solutions and new ways of working and new business models and new products at pace and scale is going to be very exciting. And normally when I'm in university crowds, I look around the audience and try and work out what age people are. If I was 25 years younger than I am now, what a time to be an engineer. across all sectors. People say, should I develop this skill set or that one? All of the skill sets are going to be needed across all sectors, across all engineering types, whether it's engineering and manufacturing, or if you're in the supply chain, if you're in the services business. It's a wonderful time to be an engineer in manufacturing. You all know that because you're here, but hopefully your colleagues will start to recognise that too. So I clearly feel that manufacturing is important, but I say when I look across the sectors, the transformation that's upon us is really, really exciting. So the bit that I actually get paid to do is the Made Smarter Innovation Programme. Claire talked earlier on about the broader Made Smarter Programme. So 2017, 5 years ago, goodness me, we talked about, in the Made Smarter report, which was led by Jurgen, talked about an integrated approach across leadership, skills, innovation and adoption. So when Claire and I work very closely together, the leg of that stool that I manage is the innovation programme. And the ambition was to be not just a leader in adopting of the technologies, so therefore making manufacturers better, but in terms of creating and exporting those technologies themselves. It's really important to kind of recognise that it's those two bits of it, and it applies in this research centre context too. We're fully cross-sector. We cover all manufacturing sectors, so suddenly 147 billion feels like a little bit less than it did in the job interview when you realise that the breadth of things you're trying to cover. But a lot of those core processes, a lot of the core technology needs are very common. It's classically the technology set of Industry 4. We focus in this funded programme around the smart factory side and the connected supply chain, less on design. For those of you who are involved in some of the programmes, there is some projects in our portfolio that have more of a design tinge, but it's primarily focused around the factory and supply chain stuff. We only had approval in September 2020, so we're pretty delighted that we've got this far with DM2 and others. And broadly, we think that digital manufacturing is a massive underpinning thing for how we mix and deliver products and services. It will be an enabler in terms of what we make. That feedback, I think Mark mentioned, between manufacturing designs is really important. It's a critical enabler in terms of resilience and the green recovery. Primarily, in the narrative for 2017, productivity was the goal. There's a lot of other metrics, job growth, growth of the sector, reduction of waste and so on. But really, it was driven by the national productivity investments that were made at the time, so it was productivity orientated. And what we're seeing is what people are really choosing to invest in is a sort of broad range of outcomes that include productivity. So the challenge is, how do I improve manufacturing and develop the technology sector? We've got 147 million, I would say, not to spend. It's because we're in the middle of, I'll show you in a second that a lot of that is allocated. Now we have to deliver the value from it, which is the challenge for Alistair and the team. We run until March 2025, so we had some extensions due to COVID. So we got pretty much less than 3 years from where we stand now to deliver all the impacts we're talking about. We took three principles. These are slightly retrospective. To be totally candid, I wrote them before Digital Manufacturing Week in November last year, as a sort of to try and explain why do we have the program we have, which I'll show you what it is. One is very much to create a connected, collaborative ecosystem. There's a pathway essentially in the program from this research centre through to fully industrialised solutions. Everything we do in the program has a mixture of manufacturers, technology solution providers, academics, investors as needed and so on involved in it. We think that consortium and that sort of approach is really important to us. We put people at the core. There's lots of strands to that. The sort of phrase at the moment is compellingly adoptable. How do you really make sure the solutions are adoptable? How do you design them with people in mind? So in terms of the platforms we have in this program and elsewhere, how do you really make sure you consider human factors? How have you thought about how that might transform the future of work and so on? But it goes beyond that, creating communities around this area. So there's 5 research centres and there are others that need to connect. There's lots of people with common issues. How do we create that community of people really supporting each other and driving forward disruption? And diversity. So diversity, not just in terms of characteristics, is really important. Claire touched on it. Again, that's a topic of its own. But also new ideas, new voices, bringing in new bits of the community. So when we look at investment in the programme, we look at that. We look at the diversity of the team. We look at, are they bringing in new voices? Are they providing new opportunities for people within this centre and others? And delivering that positive future that we want, as opposed to sort of standing here and wondering what the technology is going to do to us. And what does that future look like, and sort of dystopian views about what the future might do for us. Try and be positive about some of that. So transform future work, strengthen the resilience, sustainability, as I said, build a sort of new manufacturing ecosystem. How on earth do we deliver net zero manufacturing? It's a non-trivial problem. And I think how to conceive what that future looks like and how does digitalisation support it is one of the key areas of interest. So this is my graphic, so the arrows don't always touch the circles, so it hasn't been polished. This is raw, authentic, Chris made it up 2 years ago type stuff. But it actually came from a conversation originally with John Paul Sherlock, who I think you heard on Monday morning, where he talked about that connected ecosystem, this idea of creating a pathway from the top right-hand corner of research centres through into accelerators which really support those startups and SMEs as they start to develop the technology a bit further into our innovation hubs, which will give us an opportunity to industrialise it, and then you're into the big mainstay of Innovate UK, which is CR&D, so a lot of kind of collaborative R&D investments. We want to globalise what we do, so research centres, accelerators, hubs, everything. We want to try and extend those globally. And we've got some small pieces of work, but there's more work ongoing. And that whole issue of standards and interoperability is important, as everybody recognises, and it's important across sectors. So we build these kind of different investments. The challenge for me now is we want this centre to be really successful, but we want it to work well with the other centres, and we want it to be able to provide a pipeline of ideas that we can scale up through the rest of the programme. A few things to say. In the research centres, they're all multidisciplinary. They all have industrial, there's 132 industrial collaborators, more welcome. Find Alistair if you want to join. And that's true across all the centres, intensely industrially supported. We have a separate strand of ESRC-led work, which is more looking at economic and social policy type drivers as well. So these centres are all trying to deliver fairly transformative stuff, and I'll show you some of that in a second. Over 50% of the companies involved in the overall programme are SMEs, so it's not just here for big companies. Some of those are working in partnership with big companies, but some of those is SMEs to SME programmes. And we do a sort of strange thing for our own health and happiness, which is to look at how many people are new to UKRI, how many people are new to working with each other. And I couldn't get the precise stats, so I went for a large portion. Because we get into semantic discussion about what do you mean by new. But between 30 and 70% of that, if that helps you with the range of ideas. So that means that there are new companies coming through. So traditionally, I used to work in big companies. They will have chosen partners for these things. But what they're seeing is new partners. In the Digital Accelerator, we won one with the Digital Catapult. We had hundreds of SMEs apply that most of us hadn't heard of. So it's quite a vibrant space in terms of this technology area. So there definitely are opportunities to really harness some of that energy we have in the UK. So the research centre, the brethren of this centre are things like the morphing factories in Nottingham. Nottingham, Cambridge and Sheffield, you'll see some common constituents in each of these. Materials made smarter, looking at the life cycle of materials and how do you digitise some of that to really capture maximum value through the life of the material. A very much people-led work with Bath, collaborative robotics in Loughborough, and so on. And it's really interesting. All of them have strong industrial engagement at launch and looking to grow it. All of them leverage the social sciences input. We want to try and create communities across some of that. So we had an event in October where we pulled the research centres together. So at all levels, from the individual academics and early career researchers all the way through to Alistair and the centre leads, trying to build a community where we can, because there are common issues across all of them, as we described. This selection of this centre, I just credit Alistair and the team that they've put together. This was incredibly competitive. We were massively oversubscribed in terms of what I could afford. We could afford 4, we funded 5. I could have funded 10 and not drop below sort of 85% quality threshold. Really, really high. And I think, you know, this consortium, this approach, this mixture of industry and academia and so on is really, really important. And I think it's a really powerful testimony to what we need to try and do going forward. It's a brilliant, brilliant example, as are the other centres. I was really, really excited. It was the down select meeting for this was one of the toughest decisions that we've made during the course of the programme. There are lots of great projects, but these centres were very, very strong. So maybe just to kind of pull that together in some thought, genuinely, if I look across all sectors, whether I'm in food, pharmaceuticals, automotive, aerospace, digitalisation is a common issue across all of them. Just to give you one little anecdote, we held a session where we were looking at if we made some very rapid investments in digital manufacturing, what are the areas we might invest in? So we pulled together a session with aerospace, automotive, food, pharmaceuticals in it, and said, what are the areas of interest for you? We want to do something pretty quickly. Within less than 10 minutes, somebody from BA Systems proposed 4 ideas, and everybody said idea 3. across all sectors. I thought this was going to be a nightmare. They're all going to be arguing about different things and what different sector needs and so on. Absolutely not. There is a real commonality of interest. So we've got some really successful cross-sector projects, which is really interesting to observe. So there's a lot of sector-specific ones, but there's a lot of cross-sector ones too. So there is an opportunity to learn across a broader group. We want to try and put within this program, my intent is to try and create that sort of connected ecosystem, focus on people and deliver a positive future for manufacturing. We recognize we're only a small part of that. So I might believe that we're going to deliver it all with 147 million. That's probably unlikely, but it doesn't mean we can't try. We're going to give it our best shot to have that kind of impact. We think building the ecosystem, building the consortium will stand us in good stead for the long term. We do have research centres and innovation hubs. They've launched. Yesterday we announced the Smart Factory Innovation Hub led by Ulster University. Back into last year we launched the Supply Chain Innovation Hub. Both the research centres and innovation hubs have been funded, but there's opportunities to engage and to grow beyond that. So there's still opportunities for industrial people or others to engage with some of that. And hopefully we can try and scale up some innovation through those mechanisms. We did some technology strategy work just again within my team. Tried to look at, we've all heard the anecdotes, but how good are we at AI, robotics, additive manufacturing, and a long list of others. And the short answer is, on robotics and AI in particular, if you look at investment, startup companies, public and private investment, and startup companies, we're doing pretty well at AI. We're doing pretty well at robotics. I was surprised by that, because there's a lot of conversation about robot density in the UK being lower than anywhere else, so you come in with a sort of negative perception generally about UK capability. In terms of the investment and the number of companies, it's much higher than you might think, certainly than I thought. In AI, the challenge is there's an enormous number of AI companies in the UK. We've got real strength in it. How much of that is really being deployed into manufacturing? If you literally filter the data set for manufacturing, then suddenly it's a much smaller group. So how do we harness the power that we have in UK around AI into manufacturing? And beyond that, we have, as I think CMAC's a good, and MIC and others, a really good demonstration of how we've got some really world-leading industries. We've got some great universities. We've got catapult networks and other mechanisms that really pull those consortia together. The reason why the proposal for this research centre was so strong wasn't because my call arrived and they formed a new consortium from scratch. It's because over years, the industry, the universities and others have really worked together to build that consortium. So I think we continue to build it and going forward. There remains lots to do. That's not just my pitch to government for more money, but there is lots to do. If I look at the scale of transformation we're talking about across all the sectors, all the things that people have ambitions to do, deliver net zero, deliver the health, deliver the prosperity across the economy, and the role that digitalization can play in delivering those transformed products and business models and so on, it's got to be massive. So there's plenty more to do. And when I think of net zero in particular, I think about the fundamental change that means for a lot of manufacturing sectors in terms of their business models, in terms of what they make it, how they deliver it, how we recycle, reuse it, and so on. That's an enormous shift across an enormous part of our industry very quickly. So to rewire that whole system in the next 15 years, really, in order to get there in time to deliver 2050, it's a hell of a challenge. It creates a lot of opportunity, and hopefully the UK is well positioned to take advantage of it. And many of the people in the room will hopefully drive that forward.
Thank you. I wanted to give you the CCDC perspective on digital medicines, and I guess I'm going to have a bit of a big data slant on this and AI and machine learning slant. So first of all, just to briefly explain who the CCDC is, it's a not-for-profit UK-based charity in Cambridge. We look after all the 3D structural data worldwide, and we produce scientific software on top of that to more or less innovate and create new knowledge and find new insights and learn from the structures and understand the properties of these structures, and I guess also discover new chemistry down the road. So we do a lot of research. We work with lots of academics and other institutes worldwide and lots of industry partners. And our mission is also to train the next generation of structural scientists, because we really believe structural science needs to be pushed and grown, not only here in the UK, but really worldwide. So that's our mission. We're talking big data. It's perhaps not as big data as clinical or biology, but chemistry is still, it's a huge universe. And we've got 1.2 million molecules in the CSD. It's called the Chemistry Structure Database. We have these depositions coming in from thousands of crystallographers worldwide. So it's kind of from the world into Cambridge, but then from Cambridge back out into the world. sharing the structures and setting the standards, storing the structures. In some sense, you could think of us as we're the sort of guardians of the crystal structure galaxy. And that's, somebody has to do that worldwide, and we're a global data repository for that purpose. And so what we store, or the sort of content that we have inside the CSD, and I won't dwell on this, but just to give you a flavor, it's 50% organic molecules with all the drugs, agrochemicals, pigments, protein ligands, etc., and then lots of metalloorganics, catalysts, other things, porous frameworks, morphs, metalloorganic frameworks, lots of functional materials in there, which again we can innovate an awful lot with that for green technology and data technology, green technology and other things we will need in the future. So there is a huge breadth of science inside the database, and it's the key thing would be to explore that ocean of knowledge and learn from it and kind of do new good things and innovate. But I will say, I wish FAIR was already done. I mean, you guys have all heard plenty on FAIR, probably on Monday and Tuesday in presentations here and there. But the FAIR principles really are super important, but they're not necessarily that exciting in some way. But they're fundamental to have, you need to get them right. You have to have everything findable, accessible, interoperable, and reusable, and not only by the humans, but really by the machines. That's the key piece. And this needs to be happening here in a symbiosis between humans and machines. And so I won't go through all the details. I will highlight, though, that I think the interoperability piece is by now the strongest thing that needs to be gotten right in the coming years. And that's what we found with lots of interviews with big pharma companies where we went around and we checked all the FAIR status of where everyone's at. And the FAIR is a journey for everyone. They're all at different levels, but a lot of people are working on this. But as I say, in some ways, I feel if all the IT departments had already done FAIR for the last 20 years, we wouldn't have to now do it and work even stronger on it. But it needs to be done. Because then what you can do, you get all the interconnectivity now. And we feel at the CCDC in Cambridge that we want to connect into other data repositories around the world. So for inorganics, it's ICSD over in Germany, ICDD in the US for diffraction patterns. PDB, we want to cover the structural biology piece. So we have a number of collaborative efforts running there to cross-search CSD and PDB. And that way, if you look at this kind of universe, that's the full structural science space. And of course, we want to make that available, and we can deploy our platform here at CMAC and DM2, and we very much as platform one, we want to help and contribute and have that in the cloud. And then us as a center, we set the interoperability standards for this sort of structural data by working with all the publishers where we get the data from, and also by working with various other suppliers or machine vendors who have the X-ray structural machines, Bruker, Rigaku, etc. And we get this in proper workflows. It all comes into our center, and we have lots of data quality control to ensure that the data is of highest quality. And obviously, we're very keen to set international standards and keep doing that so everything can be interlinked. Here's my slide on how we now learn from the data and grow from this community-derived data that we have. We then have various software suites that are sitting on top to explore it, to search it, to analyze it, to visualize it. And again, all these capabilities we can deploy here at CMAC and DM2 to help facilitate, I guess, the discovery of new science, novel insights, new discoveries, and doing fundamental research on that data. CCDC has different software suites like CSD Discovery, which I won't go into today. I'll focus on CSD Materials for you. The CSD Materials piece helps us all here to manufacture drugs and functional materials and learn their properties and understand them digitally first, and then design the right thing and produce the right thing. So our core software offering, like I say, it allows you to visualize, analyze, advanced search, all the big data, and I won't go into the individual components. One thing I'd like to say here is we have this Python API, which really facilitates the interoperability, so you can access everything via API. And at the CCDC, we have about maybe 600 to 1,000 different functionalities from all the software suites, all of which are available via APIs. So it's more or less open standard, open access. You can get in there and out there with machines or humans, it doesn't matter. And you can do everything in bulk, which is very important when we come to talk to machine learning and model building and AI. The CSD Materials Suite, just briefly, here's a bunch of targeted solutions. It's all about solid form investigation, solid form assessments, and then solid form predictions. So really what you want to do by deploying this sort of sophisticated scientific software is to totally understand your solid form and all its behaviors, its properties, anything you can know about it. If you know it first digitally, if you can calculate it, you can know about it, you can do your better experiment afterwards. So it just, you got to deploy the cleverness early on, design your things first and understand everything. So you can run these solutions. And I think as we, over the last 20 years, we've more or less built so much software on top of the data, which is kind of 60 years old, because the center is formed in the late 60s. We have so much software, some of which is a bit legacy-based, and all of it is now moving to the cloud. We're doing heavy investments to get everything into the cloud. And again, there's a lot of experience here now, which, again, we can help with DM2 to deploy things in the cloud and on top platforms, because we've got all the database architectures that we can sort of share. What we now find, we for all our sort of industry partners, we see that we're stringing together the different tools in novel workflows to make sure it's quite controlled as to how you do, health checks and risk analysis on your solid form, and you get automated digital reports they're auto-produced. So that's quite powerful and very fast. So you get a lot of time savings with all of this. I will make another point here. We, as a center, we can do these things far better in a community-based approach. So we're running a consortium which is called the CFC, Crystal Form Consortium. It's a collaborative, pre-competitive approach where several key players, top pharma companies and others get together, solid form scientists, and they help us to push the solid form informatics and particle informatics and look at all the workflows that are needed in industry. And we can advance really here and innovate and, again, go digital first and have live feedback from all of these key players which interact with the center pre-competitively. And again, some of the learnings we have from here, we'd be very happy to share into DM2 and into the various platforms that are running here at CMAC. Now, speaking a little bit or moving on from the data that I hope I convinced you that we've got plenty of that and high quality standards to that and high trustworthiness of that data. Lots of scientific software on top when we're trying to generate insights. Nowadays, of course, we find with all of our projects and lots of academic collaborations we have, more than 60% have a strong machine learning and AI component by now. So there's lots of model building happening everywhere. And I take the view now, as I see, the science days, I see lots of people presenting their models, and we saw, loads of models yesterday, which I really love to see. I think we need to get to a point where we can store the models far better, version control them, let the community interact with it in two ways, to modify them, improve them, test them, publish them. So there is a lot about, I think this is one of my key points with all this AI and machine learning talk. We need reusability and reproducibility and total understanding of what these models do. They can't just all be black box. So we need white box or gray boxes. And so I think the other thing we also need in order to feed the models and build better machine learning and better AI is we need to understand the data collection and the data processes and have the data standards sorted early on and have high levels of automation to pump and feed the data into the models. Because if you don't have that, you're wasting 3 months or 6 months in preparing and cleaning up your data, and who's got time for that in the future? I think we need to reduce that out. Then you can do your feature selection, your modeling, your evaluation. You can have it peer-reviewed. You can version control it. You can run it with other people. And your models get better and better, and they can iteratively improve. So few things that I think, from our perspective, what we think are needed for facilitating better machine learning and better AI is, like I say, I think we want community model stores, which, again, we can help store models here as well. And more curation of critical gold standard test data sets that can help validate models. So you can really test your algorithms and make sure everything's properly validated. Better access, better API in highly consumable forms, so the interoperability piece is guaranteed. And then far more semantics. I don't want to have time to go into ontologies and knowledge graphs and other things, but there is huge pressure to build up way more semantics. So we store all our crystallography data in CIF 1.0 format from the IUCR, International Union of Crystallography. But the mission for the next few years would be to go to CIF 2.0, which is far, far more metadata, not just 50 fields of metadata, but far, far more. So you get way more additional semantics. And then on top of that, you could build clever stuff like voice control and asking scientific questions to your molecules. And you'll be able to actually have the systems talk back properly. It'll make scientific sense. So that's a big piece that needs doing. I'll just reiterate on this slide with the FAIR principles, and I will now sort of apply the FAIR principles to, again, the machine learning and AI models. I think those models need to be findable, accessible, interoperable, and reusable by the community. So it's not just the data, it's actually the machine learning. that needs to be following FAIR principles too. And that's sort of a novel or a bit of an innovative step here to take. Lastly, I just want to finish off on the last 2-3 slides just to talk about the concept of digital first. That's a concept we've been running with a number of big pharmaceutical companies for more than a decade. I mean, we were part of ADOPT and various other big initiatives to push this concept of digital design centers, digital drug manufacturing centers, digital drug discovery. And here, I'll just focus on the sort of, again, understanding the molecule and its properties, understanding its solid form, and then going on from there to understand particle informatics, how everything aggregates. Then you have your understanding of your physical chemical properties, and ultimately you get to your digital medicine or your final medicine product far quicker, far faster, and you can sort of optimize all your key decisions along the way because you would have modeled everything as you go. So the digital first piece is just to do it all up front, do it completely digital first, and that's your, I suppose, digital transformation is a journey. So you're just running with those principles. And personally, I think in a few years' time, we would have gotten there if we don't have to mention the word digital, because then it's all truly happening and fully powered digitally by these workflows. And if those are running in this sort of sophisticated ways that I've just hopefully alluded to in a comprehensible way, then you get top innovation. You can push your cutting-edge science. It's reproducible. You can tap into both the machines and the expertise that comes off the software and the machines, but you can also pair that up with your subject matter experts and your scientists. I think that's a key thing for the future. I think Chris said it as well. I think we want a symbiosis between the machines and the computers and the subject matter experts and the scientists. So a scientist should be totally enabled to be more creative and more innovative and more thinking and more using everyone's brain here, be freed up with that by the machines doing the groundwork underneath. That has to be a key principle here, I think, for the future. Integration, I talked about that. I mean, really, you can, once you've got this digital first concept running everywhere, it can be applied portfolio-wide, and you can have your robust models across the whole lot, or your workflow is fully stored in these models or in these model stores. And everything can be rerun reliably, it can be optimized. You can get your software developers on top of this to improve things in a quite controlled manner. So it's quite reliable. It runs much faster, of course, because everywhere you end up with automated scripts or workflows that are pushing automation. And you guys mentioned other things like robotics and IoT and other clever things that will accelerate things, make things faster. And then this produces clear savings down the line here, and you can more or less extract maximum value from the whole data ecosystem, which is really what we wanted to do all along, because the person who founded the CCDC or CST at the time, Olga Kennard, in the 60s, she had this vision that the sum of all the molecules we can have, the sum is greater than its parts, and it's one huge ocean that you have to extract the knowledge from. And so now here we are in 2022, and we're using digital means and workflows to totally more or less find the gemstones in there and find new materials, find or create APIs faster and better with new properties and things that we really want to fully understand first with these systems and methods before you experimentally have to make it all. And hopefully you can optimize how you're doing the manufacturing as well by going first with the digital principles. So I'll end here, and I'm very happy to take questions if there are any.